Okay, I think we can start. Can you guys hear us?
Yes.
Yes, all good.
Okay. So the theme of this presentation is about reactive. Some of you may think that it's just another buzzword and it's going to go away with some another technology, but in fact, it's not a technology even. It's actually a serious modern architectural problem. And the problem here is to stay within the modern standards. And some companies obviously faced the issue of staying within the modern standards, and they came up with the Reactive Manifesto, where they describe a reactive system. A reactive system is basically a system that complies with all these modern standards. And basically, simply put, reactive system is a system that reacts to stuff. It always gives some feedback to user. It answers fast and correct, and it seems invulnerable even if it's not. So even if it's dead inside, it pretends to be alive. For example, it doesn't matter how high your load is or if some of your services are down, it still needs to be responsive. And that's the main goal of being reactive, is to be responsive. As I said, you need to answer correct and fast in any circumstance. In order to do that, first you need to be elastic, meaning that you can scale up and scale down and withstand different turbulent conditions. Second condition in being responsive is you need to also be resilient, meaning you need to handle failure gracefully. If some third-party component answers inadequate or some your microservices are down, it's still you should answer fast and correct. And these companies that were writing this manifesto came up to the conclusion that in order to do those two things, you have to be message-driven. I think it's because easier to talk between the nodes of your distributed system. But the presentation is not actually about the reactive, it's just a reason for us to move forward. And if you want to learn more about reactive architecture, then there is this company called Lightband. It's one of the participants of the manifesto, and they have free online courses that I highly recommend. Here's one slide from their course, is that actually reactive system and reactive programming are very different. A reactive system is an architecture, it doesn't matter how you write your code. And reactive programming is the way you write your code. It doesn't matter how your architecture looks like. So if you use reactive programming, it doesn't automatically mean your system is reactive. But I highly recommend you to check out reactive programming. It actually makes your code elastic and resilient, which obviously helps. And as there is a reactive manifesto, there is also a reactive streams specification that is intended for reactive programming. They both are under a couple of pages, and reactive stream specification basically defines a couple of interfaces that allow you to easier work with multi-threaded asynchronous code. And reactive programming is all about using your threads as efficient as possible, and it's difficult to write in that. And the specification doesn't only target languages, but also network protocols. But this talk is also not about that. We're going to be focusing on the foundation, on the message-driven, and specifically we're going to talk about event-driven first. And it's important to distinguish the event and message. They're not the same thing. Event can be a payload of a message, but event-driven, if you are event-driven, it doesn't mean you're message-driven, and vice versa. If you're message-driven, doesn't mean that you're event-driven. But it's actually easier to be. It's easier to become message-driven if you are already event-driven, and it brings even more benefits. So we are going to build. We will have a simple MVC application, then we will make it event-driven, and then we will make it message-driven again. Then we'll make some conclusions on that. So what is event? It is a fact, basically what happened in the past and you cannot do anything about it. For example, account is closed. You cannot undo this change. You can reopen the account, but the fact that it was closed for a brief moment stays. And for that, for implementing event-driven system, we'll of course use publish subscribe design pattern, where you basically have a bunch of publishers, they publish some event in the event bus, and anyone can listen to it. So if you compare the MVC simple application to the event-driven system, basically you call it the same way, like in the left MVC, in the right event-driven, but the component itself will, under the hood, publish some events on the bus. That's the only difference. And what if we just logged these events, right? So we have the same application acts the same way, but it just publishes some events. We can just add one single listener that will only just log it, whatever comes to this listener. And that already brings us a lot of observability to our system, because it's a lot harder to forget to put event publishing statement than logging statement, because logging is not really a part of your architecture. You don't think about it in terms of design. You can easily forget it, and you don't even think what data is relevant to this login statement. While in event-driven system, you always have events, because you may even break something if you don't publish an event. And that's just the tip of the iceberg, of course, what you can do with all of these events. You have a lot of information available. You can feed it to any system. So first, we'll have the first demo. It's basically...
Yeah.
Sorry? So the first demo will be just, I'll show you the simple MVC application that we have. Let me just go to IntelliJ. So I already have it running. You may know this application from our advisor presentations, but it's heavily modified. So we have this class, bike. It's basically a bike rental application. It has 3 fields: ID, location, and renter. And it has 3 methods. You can create a bike at certain location. You can rent the bike to someone, and you can return it at certain location. And it has some validation that you cannot rent it if it's already rented, and return it if it's already returned. So we have basically Spring Data GPA for the repository. We have a service that just calls this repository and does all of this stuff. And we have a REST controller that basically only calls the server and exposes a CRUD API. So this is the CRUD API that we have. And the application already runs. It's already running. So if we send this request, we get an ID back. We can then rent the bike. And you see it rented to alert, and then we can rent it again, but it's already rented, right? So we can also return it, and then we can see the actual result. Very simple application. Now, now we will go next with our slides. Wait, no, we wanted to add events, right? So it's pretty easy. We will just go to our Git log and reset to the next commit. And the only difference that we have right now is that first we define these events: that bike registered, bike rented, bike returned. And we basically add some event gateway that we use from our magical framework. It's called event bus. And all we do is we just add these statements that we publish some event. And in the end, we also add an event handler that basically logs all of these events. So we have this application. We can stop the old version, run the new version. I'll just make a post request and you'll see that the bike registered event is logged here. It basically acts exactly in the same way, but you can see that it logs the event. Okay, now we can continue with our presentation. Next, so we wanted to be message driven, right? But we are not message driven yet, because in order to be message driven, all the components have to talk through messages, and right now we talk through REST API. And also, in fact, we are not event driven even yet, because we just publish these events, but we don't do anything with them. We only log it, so it doesn't actually have count. So in order to be message driven, we need to add this request bus. We can still use our REST API, but under the hood, we can translate it with some gateway to messages. So we'll do it right now. And in terms of time, I'm not going to show the actual application in action. I will just show you the diff. That will be a lot easier. And trust me, you can check out this repository later. You can basically reset to any commit and it will run and act in the same way. So, first of all, of course, we add these requests. We basically map these requests to an object, right? So whenever, like when we send the post request, like register bike request, we have location there, right? We register bike at some location and we provide an ID right in the request. So we basically wrap our REST API in objects. And then just as we used the, just as we used the event bus, we'll auto-wire request bus into the controller. And you can notice that instead of calling the service, we now call only request bus. So this is how it looks like. First of all, this framework that I'm using, Axon framework, this command bus, basically request bus, it returns completable future, but it doesn't matter for us. We can just forward it to MVC framework and it can handle it. So for us, no difference. So just take an example in register. We call service register with these two ID and location. And here we again pass the ID location, but we pass it in the form of object to this request bus. So not much to it. And in the service, we put these annotations from the framework again, so it knows where to route these messages. So instead of accepting just ID and location, it accepts this object and has to unwrap it. And through the annotations and reflection, this framework can actually route stuff. And it works in exactly the same way. If I run it, it will do the same thing. So let's continue with the presentation. So what did it give us? Location transparency. So first of all, we are already message driven because all of our interactions happen through messaging. But the only difference is now we don't actually have any idea where this component with actual business logic is located. Now we're talking about the bike service. We just blindly throw a request and it routes itself. So the location of the logic for us is actually transparent. This gives us isolation. And what you can see in the slide here, the picture, is actually representing a monolith split into microservices. So imagine what would we need to do in order to split our application into multiple microservices. Right now, when we have a messaging system, if we just put this bike service into another JVM, nothing would change because the messaging can route itself, of course, just fine. So that's what we're going to do right now in our next demo, very short demo. It doesn't let me out of this. Let me try again. Okay. So what we're going to do is we will split our application into 3 microservices and a gateway. So you remember these, so that was before our bike service, right? We had register, rent, and return so-called command handlers. And all we do, we just put these methods into separate classes under separate Spring profiles. So you all Spring experts, you must know that if you put add profile annotation, for example, on this registration service, then it will only register in the Spring context if I actually activate this. So that's basically what I did. They only share all of these applications, except for the gateway, of course, they share only these read requests, right? Find all and find by. They can be load balanced through the microservices. And of course, since we have 3 microservices, we now will use some help from the framework itself. It's called Accent Server. It's basically going to route our messages through the different GVMs. And of course, as I said, we have several applications here. So gateway and 3 services. So let me just start them. And what we're going to do is we're going to call again this API, and I will show you in the logs where it is routed. So of course, if I execute the post request, it's going to register a bike, so it's going to appear only in the registration service. So first, let me clear the logs really quick. Okay, so we send a post request, and it appears in the registration service. Okay, bike registered request. And no one else, of course, knows it. You can also see that in the bike rental service, we received the bike registered event. Well, for this demonstration, I couldn't configure it, but ideally it would appear in all three of them. So if you're interested, you can watch the repo. So anyway, we can execute the rent command. It appears in the rental service. We can execute the return. It will appear in return service. And let me clear the logs. We can, of course, retrieve this object, and it will be load balanced between all of these 3. So the first request went to the return service, second request went to the rental service, and so on. So that's it for this short demo of location transparency, and we must move on. Okay, so next topic I want to discuss is the accidental complexity. So we want to use best practices during the modeling of our system, right? We use domain-driven design and all of that. We try to split our domain into subdomains and make it as simple as possible for us to maintain. So one domain for one microservices, it's the strategy that we use today. And even that can bring some extra complexity, which is there somewhat accidental. So you can use part of your domain in one place, part of your domain in another place, but you never actually use it in all at once. So where you do use your domain model, some parts of it actually is somewhat irrelevant. So for example, we have our simple application, right? It barely has a couple of classes, but there is already a case of that. So let's look at our write operations. So for registration, there is no validation, right? And for rent and return, if you think about it, we actually only care about if the bike is available or not. We don't really need all of this. I mean, 2 fields, renter and location. We could still have the same logic if we had only available Boolean flag, right? So why would we need these 2 fields? And the answer is, of course, obvious, because our read model needs it. So we have these 2 fields in the UI. So the user, which, for example, looks at our website of the bike rental shop, he needs to know where this bike is located. And an employee which tracks down all of the missing bikes, he needs to know who rented it. So there is a design pattern that can help us with solving this problem. It may seem like a very little problem, but if you work on this application for a couple of years, it may actually grow big. So the pattern is called CQRS, Command Query Responsibility Segregation, and it is based on two definitions, on command and query, where command is basically a write operation and query is a read operation. So you basically divide all of your requests into read requests and read-only requests. I mean, write requests and read requests. So command would be like post, put, or delete in HTTP, and query would be like get. And in this term, it's actually very similar to single responsibility principle, because you separate the responsibilities here. So if we take an example in our application, we would split our requests like this. Basically, we just rename them. It's just a semantic change. But this pattern is not only about that. It's actually about dividing all of your writes and all of your reads, meaning that every single object that you have gets split into two, where one is only responsible for making decisions and another is basically a view. So we can make our write side, which is the most complex part, very simple. I mean, not very, but a little bit simpler, which helps a lot, of course. And another thing is that we may log our commands always, for example, and log queries only on demand. So there is only also a tracing benefit to it. So what we need to think about also is that our writes need to impact our reads, because we split them. Whenever a write component makes a decision, it needs to somehow notify read component to keep it in sync. So in our example, we have bike and bike view, where bike makes decision and bike view returns something to front end. So if we want to rent bike number 1 to alert, then our write model simply flips the availability flags to false. Then it sends some notification to the bike view that this bike number 1 is now has a new renter, and his name is alert. So bike view takes this string from the object and puts it in its own view, so it updates itself. So whenever we actually get a query, which obviously targets only read model, so bike will only accept commands and bike view will only accept queries. So whenever we receive this query, the bike view is actually able to provide the same output here. So what do we need to change for that? First of all, we need to split our requests into commands and queries, and then we need to split our model into read objects and write objects. And just to summarize, now we have 3 types of messages that we mentioned. First of all, we know that event is not a message. It is simply a payload of a message. And same with the request. Request now is also a payload of a message. And request can be either command or query. So now we have a message that can be either of 3 types: command, query, and events. And they are routed a little bit different. For example, command can use consistent hashing to always hit the same machine. Queries can be load balanced, and events can go to all of the listeners. And luckily, Axon framework that I'm using here has a first-class support for all of them. And I'll show you how we can implement it. It's pretty easy with the Axon framework, and I will again only show you the diff in Git, because that's shorter and we are really pressed for time. So first of all, we go into a zip application back into one, because we just showed off that we can split our service into microservices, but you don't just go randomly split your service, right? So first of all, we separate our requests into writes and reads. So before we had register bike requests, then we register bike command. Okay, we had bike get bike by ID. It was request, now it's query. It's simple renaming basically. So we rename our requests. Then we introduce a query gateway. So before we used command gateway for both commands and queries, which is conceptually wrong in terms of this framework. Now you can see that command gateway actually makes sense here. So they have different gateways that, as I said, routed differently. So before we used request bus, which is actually command gateway, and now we use command gateway. It's basically only renaming here. The only difference is in the write requests. So we used command gateway before, and now we use query gateway, which has a tiny bit different syntax, but it's pretty much the same. And another change here is just renaming, and one change is that find all and find by, they were annotated with command handler, now they are annotated with query handler. So that's basically all you have to do in order to implement the CQRS, I mean for the requests part, right? Now we're going to separate our models into read model and write model. So this was the before, right? This was the before. We only had one bike service that handled both commands and queries. Now, first of all, we move this event listener into a configuration class because it doesn't really belong anywhere. Then we put everything that we already had into a write package, and we change, first of all, these two fields, location and renter, we change them into available flag. And you can see that the logic became a little bit simpler. Then the repo just changed its package, and the service is exactly the same, except it doesn't contain the query handlers. And now we create a view, which is another entity. It's a separate object here. And it has all of the three fields, but it doesn't have any domain methods. It doesn't have any logic because it's a view. It has its own repository because it has its own table, of course. And it has the service. And here we actually become event-driven because we have legitimate event handlers. So whenever we receive a bike registered event, this is a fact, right? So we just update our representation bike view. In this case, we just create it. And in terms of rent, the same thing. We basically catch all of the events and update our representation. And here we can see our query handlers. And in rental controller, the only thing that changed here is the return type from bike class to bike view class. Everything else is the same. And just trust me on that, it works. Okay, and next slide would be that Axon Framework can do better. So while we're here, just save some time. Let's refactor it a bit because Axon Framework can give us a little bit more. First of all, we can remove the repo at all. We can rely on our framework to call the GPA repository itself. All that we need to do is just add this annotation, Axon Framework aggregate. And the aggregate here is from the DDD, from the main-driven design, is basically a thing that manages something. In theory, it can manage some other entities, and Axon Framework has aggregate member annotation. It's like a car manages wheels and this stuff. Basically here it's aggregate root and manages itself. And here, instead of auto-wiring the Spring Data GPA repository, we auto-wire Axon Framework repository. And it has a little bit weird syntax because you're not really supposed to use it like that, but you can. And just for the presentation, it's easier to look at. So we do the same thing, but with Axiom Framework. And then it can do a little bit better. We can actually remove the service also. And what we need to do is we need to put these command handler annotations on the methods themselves. So for example, you can put this on a constructor, and you can accept the command here, and you can unwrap the parameters. It works that way because aggregate annotation here is actually a Spring component with a prototype scope. So you can actually auto-wire anything if you put a comma here. And in the service, we used event bus, right, event gateway. Here we can call this aggregate lifecycle apply, which under the hood does exactly the same thing. It calls the event bus. So we didn't change any behavior whatsoever, but we got rid of some code. We actually need to add this annotation here on the commands because before, if you remember, we received this command and then we call, like in rent, for example, right? We call load and then we pass the ID. Now we don't have it, so Axiom Framework needs to know how, like, which instance to route it to. And in order to know that, in your command, it needs to see some ID, and you need to tell them which field it is. So that's it for this part. So we can continue. More demos for Axiom can do better. And then imagine what we could do if we just stored our events. So right now we're event-driven, but we're getting into event sourcing. And event sourcing is based on the fact that you store all of your events. And it has a lot of benefits. And just to demonstrate, let's quickly implement the event storage here. It's not going to take a lot of time. So first thing that we'll do is we'll make the database persistent, right? Because right now we have H2 database on the class path, and by default it uses in-memory representation. So we change it into the file database. And second, Hibernate recreates it every time we start it. So we make it only to update, meaning to create missing parts. And we use JSON for the event serialization because it uses XML by default. And let me stop all of these. I forgot to stop them. Also, we need to make sure our database is cleaned before we start our application. And that's it. That's all we have to do because Axiom Framework actually does store all of the events by default. So all we need to do is just start the application. And then we will fire a couple of events and I'll show you how they are stored. And then we can proceed with our demo and show the real benefits to them. First, we create a bike, then we rent a bike, then we stop the application, then we go to this database. Here are the two tables, bike and bike view, that are ours. All of the other tables are created by Axiom Framework. You can obviously rename them, put in a different schema. It doesn't matter for this demo. So what you can see here is all of the events that actually happened. So first was the bike rent command, bike rent event, bike registered event, and bike rented event. And here are the payloads, right? And another thing is that the aggregate identifier, meaning the bike ID, and sequence number, because these events are, they have an order, right? So okay, we implemented event storage. We store all of our events. Now what does it give us? Let's talk about that. So there's this interesting quote by the CQRS pattern inventor, Greg Young. Most systems actually require multiple read models to work well. And this is what is meant by it. So you have your write side and you have your read side, but you don't have to only have one read side, right? Because you have just a notification system, like an event-driven system. Any number of subscribers can listen to your events, so you can have multiple read models for that. And you can do all sorts of fun stuff with it. For example, you can create some read model to use NoSQL database, another to use to be some data science system, another to use some full text search indexing, and everything. Basically, you can scale it horizontally, and basically you can tune your read models for read performance. And it's also gives us a little bit of high availability because you can deploy, obviously, all of these views and writes separately. So if your logic write component goes down, you can still serve requests through read models. So what we're going to do is we're going to add one extra projection. So this read model has a couple of synonyms like a view or projection. So we'll add a bike history projection here. It's also not going to be long. And it has some interesting side effect here. So create bike history projection. We just, in our read model, we add another package. This is just moved to package, nothing changed. So we create bike history view, which is entity, and it is immutable. It's a Hibernate annotation, meaning it won't update anything even if you try. And again, it doesn't have any logic, but it has different model. Right? So it has, first of all, its own ID, which is generated. And then it has basically it's a bike history, right? It has just, it logs what happened. So for bike view, at this time, something happened, which is a string. You can supply anything you want. And obviously it has a data GPA repo. And we want to receive all entries for a particular bike ID to see the history of what changed to this particular bike. So we have, in this bike history, we have again event listeners, and they basically feed on these events. Except for, you can see this timestamp here is an annotation from the framework I have. As you remember, the event is not a message, right? Message has some metadata in it, and timestamp is included automatically. And you can also have some other metadata, but this one of it. So whenever we register a bike, we save an instance of this bike history with this string, bike registered in location, and bike rented to, and all of that, right? And it has its own query handler, find all by ID, that basically returns all the instances of this. So we will start this application again, and you'll see how it works. And it works in an interesting way that first it starts, and then, so this is our new endpoint. It ends with history. We run it, and it already returns us everything that has happened to this bike from day one. This is an interesting thing, that one of the benefits of the event sourcing. And this is called a replay. So what event sourcing gives us is the power of not now. Means that event sourcing captures basically everything that happens to your system, right? It doesn't necessarily have to go to one of your models at all. So everything that goes through your systems gets stored in event objects, and these event objects are stored in a database. So what you can do with it, just as I showed in the previous slide, that we just add a bunch of event listeners, and they obviously keep track of where they left off. So if they're new, they just replay everything from day one, and they can build up their own model. So for example, it's very powerful for analytics. Imagine the boss comes in and wants some report, right? And it doesn't matter what he wants because we capture everything, and we can just put some event listeners to build up a dump that he wants. And we also get to defer some architectural decisions, meaning that we can think about our view models a little bit longer and not be afraid that some data will be lost while we're thinking about it. Another thing about event is not a side effect of a change. It is the change itself. It is the source. Projections are sourced from these events. As you can see, they listen to the events, and depending on what is inside this event, they just adjust themselves. So they are sourced from the events. This is why it's called event sourcing. There's this interesting quote by Allard, the CTO of Access Framework. If it happened, it's in the source. If it didn't happen, then it's not in the source. So in our case, the source is this the main event entry SQL table. This is the source for us. But actually, we're not entirely our system is not entirely event sourced, because if you think about our write model, it does some actions, some validations, then it updates its fields, like the availability flag, and only then, post factum, it publishes an event. So it's not sourced from the event, right? It's like a side effect. So we can also fix that part, what we're going to do right now. For that, we change the persistence of our bike from being stored in the SQL table to just read the main event entry table with the events. So every time you start the application, it will replay all the events and keep an in-memory state. So it is actually stored as a bunch of events here. So the first change, of course, is that we remove the entity annotation. It doesn't need a table anymore. And because we remove the @id annotation from the GPA, we need to replace it with something else, because before Accent could understand that it is an ID. Now we can use Accent-specific annotation. And by the way, this and this, it's just Kotlin syntax. It doesn't matter. Nothing changed here. Next, what we do is that you can see before we changed our state right in the command handlers. So we remove all of these parts and we put them in separate methods that have specific annotation. Event sourcing handler. This is a specific kind of event handler that can only be inside an aggregate. And with this method in Accent Framework, there's an interesting thing that before actually publishing the event to the event bus, it first tries to find all of the event sourcing handlers, execute them, and only if that's successful, they publish it into the event bus. So it behaves in exactly the same way. And if I start the application, it will just replay everything and know its state. So it's not gonna start too long, so we can show that. First of all, we don't need the bike table, right? Because it's not an entity anymore. And then we can use, we have main projection and history projection. So let's use our main projection to see what is the current status. So if you remember, we only created and rented it. So if we try to rent it again, the right model should throw an exception, and it does. So it works exactly the same way, except that we now are truly event sourced. Okay. And we are finishing very soon. We have 10 minutes left. So event is immutable. Of course, as I said, if you close your account, you have to reopen it. You cannot undo what you did. Imagine Git versioning system without the base and force push. That is exactly the definition of event sourcing system. So your code is actually event sourced, and they solve a lot of problems with this. For example, if you have like 1 billion of commits, then it's hard to replace. So they have some snapshots that help you to load faster and all that. So it's not actually a problem at all. Another thing is that can we prove that our logs are correct? Like we have some logs, right? Can we actually be so sure that we can go to court with them? With event sourcing, we actually can do it because it is the source of truth, and we have this framework that basically forces us to do that. And we can even make sure that nothing can be overwritten on a hardware level. So we can use some worm drives. Another thing is, how do you refactor your model? Let's say you have a bike or bike view or whatever. Like in a simple application where with SQL database, you rename your column, right? And you create a database migration. Here it's not the case. You can just drop all of your databases and replay from events, because the real source of your data is event store, not your databases. You can just change whatever you want and then simply replay everything. And if you remember from location transparency, it doesn't actually matter how many projections we have, right? Each projection can have its own database, and they can run side by side without any problems. They can source on the same events, and they can produce different models, and they can use different databases. So in the case of migrations, we can have old microservice running with its own database, and new microservice running with new database, and another microservice in the process of migration to another version, right? Building up another database. So just to summarize, what did we get from all of this? We still have the same application that we had in the very beginning, the simple MVC application. We have the REST API. It works exactly like it did before, except that we now have location transparency. We have improved modeling, which is the most important part, I think, meaning that we get to get rid of accidental complexity, and it is a lot easier to reason about our logic. So it's a lot simpler to say that, well, I have this validation, I performed it, and then I decided that this happened. That's it. And before, it would be like, well, we performed this validation, then we changed these fields, and if we look at the logs, we can see that these fields changed, and this change probably means that this happened. So it's a lot simpler to actually do all this stuff. Then you have an absolute audit trail of what happened in your system. You can very easily understand what happened and what didn't. And it's very powerful for analytics, because you can just create new reports with ease. Then it's also easy to test these kind of systems, because you can just use given when then testing, where you say, given these events in the past, when I execute this command, I expect more events. And also we have smoke testing. This is a hypothetical thing that, for example, you could capture all of your commands and all of your events in some form, and then take them from the past week. You can take all of these commands and events from the past week and apply it to your current system and see if it reacts differently. Another note on the Axon framework, it's been very helpful and flexible to work with it. We could very gradually introduce it to our system, and it still works the same way. Right now, we're at the point of textbook usage of it. And in fact, it is actually built for event sourcing and CQRS. It's open sourced, it have active community and so on. Now, if we take a look at this reactive manifesto diagram, right now we are message driven, and it's pretty easy to become responsive with this foundation that we have. So in order to be elastic, we can just spread our load using location transparency benefits. In order to become resilient, we can add some error handler interceptors, and then we automatically become responsive. And if we go back to the location transparency really quick, so this is how we could implement the communication between all of these microservices, right? We need some messaging like RabbitMQ to publish events and commands and route them. We need Spring Cloud Netflix, for example, to do service discovery and again routing. And we could store our events in some database like MySQL. And Axon Framework recently released this Axon server that does exactly all of this stuff, but it's very simple to configure. And of course, it has a paid enterprise version with clustering and all the stuff that you actually need in production. But there are alternatives to it, like an event store. It's literally called Event Store from Greg Young team, which is free, open sourced. It has an HTTP client and ACK client. We have 2 minutes left, so I'm not going to show the last demo on this tracing. I'm just going to show you this screenshot. So with all of these event handlers and message handlers and all that, it's kind of hard to keep track of what's happening where. So you can actually integrate it with open tracing. Here you can see Jaeger UI, which is one of the implementations of the open tracing. Another would be Zipkin, for example. So we could annotate we could add basically a lot of message handlers, which Axon Framework allows us to do. And then we can see a tree structure. For example, here we can see that we do register API operation. It causes register by command to be sent, which causes a handler for this command invoked, which causes this event to be published. And the publishing of this event causes our projections to be updated. And if you click on each of them, you will see some objects attached, some additional logs that have key value pairs and all of that. So, and when you look at the logs, you can see where you have, for example, bike register command, then register bike registered event, and all of these logs are prefixed with the tracer ID. So that's it for the whole presentation. And here's my suggestions. First of all, I really highly recommend you to take a look at the Greg Young's presentations on CQRS and event sourcing on YouTube. It really adds to this presentation. And you can see all of these. I will share the slides after the presentation, and thank you. That's it.
What are the cons of all of these, the backsides, the negatives? So
The negatives. I asked a couple of people, and they told me that it's kind of hard to reason about the versioning of the events, right? So even Greg Young wrote a book on versioning events. So basically, you define your events, you design them, but when you want to change how they look, it becomes a little bit harder to do. So when I asked a couple of people there at the conference where they talked about this, when you should not use it, they answered that you shouldn't use it when you don't fully understand your domain. So like if you're just starting with your projects, it's probably will be kind of hard. But for us, where we have this huge monoliths like account manager and stuff, I think it would be really helpful for us. And that's pretty much all, I guess, that I know of the minuses of this.
So it not uses more storage or something? More
storage, yes, obviously.
Work.
Yes, storage, it will use a lot of storage because you store everything. Yes, but it shouldn't be a problem in our modern digital, like the storage is pretty cheap, and no, it shouldn't be a problem. Nobody considers it a problem, really.
So you wouldn't use it for like MVPs and very young projects, or what did you mean by that?
Yeah, basically that's what I understood, that you shouldn't use it for very, very young projects.
But then you will not have the whole history, right? Because
Right.
first you play with it, and then you have your account manager for 5 years, and you are ready to go. But you won't have this 5-year history, or you will have to extract it.
Well,
you will have some kind of.
Yeah, well, I guess what they really meant is that you should spend some time before releasing to production.
Yeah.
I guess that you have to figure out if you're really sure, and then if you read this versioning events, it just contains under 100 pages, and it's actually free. There are ways to version your events, so it can be handled.
Do we have
So,
any
yeah,
projects in these where we are already using this framework?
No, I don't think so. But I hope that we will.
We have a project which uses architecture, the new onboarding stuff.
Yeah, let's try out.
Yeah, there is no doubt that reactive system architecture is pretty mandatory right now. We cannot say about reactive programming, though. It really depends on your use case. For example, there is two frameworks which Spring maintains. There's Spring MVC and Spring Web Flux that both do exactly the same thing, but they don't deprecate MVC because for some cases you can still use the old paradigm, the sequential, not asynchronous. And Axiom framework is just one of the frameworks that allows you to build this message-driven event sourced system with ease, which of course you don't have to use Axiom framework.
I have a question about CQRS and this Axiom framework. Is it possible to update view models in the same transaction, in the same command, without publishing an event?
Well, with transactions, with transactions, it's kind of a little bit harder in this kind of event-driven systems because you cannot do the actual AC transaction here. It's all eventually consistent. It's like when you go to a restaurant, you order a burger, you wait for it 5 minutes, and then waiter comes and says, "Oh, we're out of beef," for example. So it's eventually you get your events. So all of your methods are basically void, and then you receive something back later. So for example, when you create a bike, yes, you get the bike ID back. But when you do some complex business transaction, it's actually called in this framework a saga. So they have separate separate definition for that. For right now, this application is pretty simple, but when you have some complex business logic there, you can really, like for example, you execute one command and it causes 5 more commands. So you cannot really wait forever for that. So it's all asynchronous and it's managed. It's a separate kind of, it's like transaction, but not really. So yeah, like this.
How do I introduce new fields, new metadata? Let's say for now I want to manage that which bike has which color. And before that I did not care about it. But what happens?
Well, I guess you need to update your event, right, in the bike registration. So bike registration event will now have an event, and bike registration event will have 2 versions. So you'll have to with versioning. So on your event listeners, you will have to deal with like whether you capture only the new version, if you capture both versions. When you capture the old event version, what do you do? When you maybe you set some default, I don't know, like white. So it would be like this.
So there will be an event about that. From now, this bike is green, and if some bike doesn't have an event like this, we consider it as default.
I guess. Yeah. Or maybe you decide to keep it nullable. But then it would be weird because it's nullable only before a certain date, and then it's not nullable. And again, with the transactions, yeah, it's all about eventual consistency here, and there's a whole huge topics on that. And to be honest, right now I don't feel confident in it yet, but I'm in the process of learning. Okay, thank you guys.
Thank you.
Thank you.
Yeah, I actually like this red young presentation a lot. He's like a very good speaker.
Yeah.